Hello. The video that you're going to see is a 1.1 and 1.2 review worksheet. It says 1.1 to 1.3, but the first page and the second page are mainly 1.1 and 1.2. Okay? So it goes on a little bit more to 1.2. A little bit more in depth, but we are stopping at 1.3, okay? So I will do as much as I can with this video. I probably won't be doing all of the problems because the answer key is on the Schoology page. Now, in the first problem it says for each given angle, which is T in other words, sketch the angle, find the quadrant, and give one positive and negative coterminal angle. 19 pi over 3, now 19 over 3, 19 over 3 is, or 19 thirds, is 6 1/3. And in order to sketch that angle, 6 1/3, you're going to go around 3 times because each time around is 2. So 1, there's 2 pi. There's 4 pi, and there's 6 pi. Now, 1/3 more is what you need, all right? So this is the sketch of 6 1/3 pi, or 19 pi over 3. That's what that sketch looks like. Now, the negative 5 pi over 4, negative 5/4 is negative 1 1/4. So that is negative 1 pi, which is halfway around, and then 1/4. So this is negative 5/4 pi. And when you sketch these angles, you have to try to get what quadrant you're in. Now, the quadrant for the quadrants, remember, go 1, 2, 3, 4, counterclockwise. So 19 pi over 3 is in quadrant 1, and negative 5 pi over 4 is in quadrant 2. To find coterminal angles for these problems, you have to add 2 pi and subtract 2 pi. You may have to add or subtract 2 pi more than once, so you might have to do that. So the positive coterminal angle is you're going to take that 19 pi over 3 and you're going to add 2 pi to it. Okay, so 6 1/3 plus 2 is 8 1/3. Right? Now another way to see this is 25 pi over 3. Now that's the positive. Okay, so another way to see this too is another positive coterminal angle is this pi over 3, but if you can see that, that's better because anyway, the coterminal angle, another positive coterminal angle is just pi over 3. So that's a pretty cool thing to be able to see that. All right. Now, the next thing we want to do is find a negative coterminal angle. Now, this gets a little tricky because you might have to subtract 2 pi many times, right? So 6 1/3 minus 2 is 4 1/3, but it's still positive, so we got to keep going. Minus 2 is 2 1/3. All right, got to keep going. So minus 2 again is 1/3. Now you get a minus 2 one more time, and you're going to get negative 1 2/3. So negative 1 2/3. Now if you did 1 times 3 plus 2 is 5, so it's actually negative 5/3 pi. That's the negative coterminal angle. Okay, so for this one, you're going to take, for this one you get negative 5/4 plus 2 and negative 5/4 minus 2. That'll give you the positive and negative coterminal angles, and you can check the answer key for that. I think the answer key is somewhere around here. So I think that was like negative, yeah. Okay, all right. Now, moving on then to the degree measure. And it really works the same way, right? So 360 degrees is equal to 2 pi. So you go once around. So negative 510 is negative 360. Another negative 360. Another 270. How far do I go? Let me look at the answer key for that one. The math on that is the adding and subtracting business. Okay. So negative 510 is another 150, see right there. And then you're going to get a 30-degree angle right there. Okay? So these work the same way to find the positive and negative coterminal angles, where you have to add 360 or subtract 360 to find the positive and negative coterminal angles. Okay? And you're going to be doing the same one for number 2. Okay? All right. The next topic in section 1 was changing degrees to radians and radians to degrees. So to convert 13 pi over 9 into degrees, you're going to multiply that 13 pi over 9 times 180 over pi. And the pi's cancel, and the numbers cancel, okay, and you end up with 260 degrees, I believe. And then to convert it to radians, what you have to do is you have to multiply this by pi over 180 for that. Okay? So that's what you have to do for that. All right? And then I think you can check the answer key for that. Oogie dookie. So the next thing you're going to do is evaluate. This is moving on to 1.2, right? So evaluate the 6 trig functions for the value of t that you're given. And the formulas that you use for these are the sine of t is equal to the y value, the cosine of t is equal to the x value, and the tangent of t is equal to the y over the x value. And then the cosecant and the secant and the cotangent are reciprocals of the sine, cosine, and tangent. So for example, you want to find the sine of t, and t is negative 5 pi over 6. You got to use your unit circle, right? So you're looking at negative 5 pi over 6 on the unit circle. Well, negative 5 pi over 6 on the unit circle is this value here. Oops, I went too far. Right there. So the angle, negative 5 pi over 6, is sketched out like this. And then you're going to find the x and y values. So x is negative square root of 3 over 2. And y is equal to negative 1/2. I'm pretty sure that's what it was. Yeah. Okay? So here's your x, here's your y. Substitute those values in. The sine of t is equal to negative 1/2. The cosine of t is negative square root of 3 over 2. And the tangent of t takes a little bit of algebra, but you're going to put the negative 1/2 over negative square root of 3 over 2, right, which is negative 1/2 times 2 over the square root of 3, negative. The 2's cancel, the negatives cancel, and you end up with 1 over the square root of 3, but you have to rationalize that, and so that's the square root of 3 over 3. Now, the other trig functions are the reciprocals of what you have here. So the cosecant of the t value I'm looking for is negative 2. The secant of the t value that I want is 2 over negative square root of 3. And I have to rationalize that, so we get negative 2 square root of 3 over 3. And the cotangent of the value of negative 5 pi over 6 is going to be square root of 3 because it's the reciprocal of this. Okay, so now how do you do 630 degrees, right? So if t is 630 degrees, well, you still got to go to your unit circle, okay? And you have to sketch out 630 degrees and find out where that is, right? So where is 630 degrees? Well, this is 360. Oops, I went the wrong way there. 360. Well, let's do 630. Take away 360 to see how far I have to go. So this is 7, and this is 2. All right, so go 270 more. So I'm right here. So that x value is 0, and the y value is -1. So x equals 0, and y equals -1. All right, and you can see what you get is these values here. All right, they're 630, and you get okay, so I am going to finish up this video. Now, I left off with number 4, and on number 4 you can see that we have a value, for example, the cotangent of the angle is 0, but the tangent of the angle is undefined because it's y over x, and at this point x is 0, the 630 degrees. So some of these values might turn out to be negative, okay, or might turn out to be undefined, not possible. Number 5 says find the exact values of the trig functions. We apply this value to x and this value to y, and then that gives you the values of all the trig functions based on the formula that we had at the beginning. I don't think it's on this sheet, but it's the sine of the angle is x, or the y value, the cosine. This is the y value, this is the x value, this is the y over the x value, this is the 1 over the y value, this is 1 over the x value, and this is the x over the y value. So they're reciprocals of each other. And you can see some of the work there. Okay, and number 6 is from the cofunctions, not the cofunctions, the even-odd functions. The cosine is an even function, so this is a formula. So, for example, the cosine of -t is the same as the cosine of t. So the cosine of -23 pi over 6 is the same as the cosine of 23 pi over 6. Okay? So you then look at 23 pi over 6, and you find the x value, and it was negative square root of 3 over 2. Okay? So again, the even function, if the cosine of t is 4 over 7, then the cosine of -t is also 4 over 7, because they are equal to each other. The cosine of t is equal to the cosine of -t. It's because it's an even function. Now the tangent, though, is odd. So if the tangent of -t is 2/3, then the tangent of t is positive, or is negative 2/3, because they are the tangent function is an odd function. All right. So yeah, all right. So then moving on then to the arc length problems. Okay. So the arc length problems are really tricky, and it's no, these you might be tested on, but the rate problems, you're probably not going to see this problem. Okay. This is a unit conversion problem that is really quite challenging, but not out of the realm of possibility. You have to apply the formulas to the arc length and the sector area, okay, to get these problems. Now, I am almost out of time for this video because I only have 15 minutes. And I got to go, it's 3:30. I got to go work out or something. I don't know, go exercise, all right? So anyway, I hope you're having a good day, and I will answer any questions that you might have. Thank you. Bye.